Have you ever watched a neat line of ants marching across your floor or garden path and felt the urge to interrupt their tiny parade? What if you suddenly placed your finger, a leaf, or even a drop of water right in the middle of that moving line? What would happen to those little workers who seem to know exactly where they're going? Would they panic, get lost, or maybe find another way? Today, we're going to uncover the hidden science behind this question and explore what really happens when you block an ant trail. And trust me, it's far more intelligent than it looks. Ants may be small, but their communication system is one of the most fascinating in the animal world. They don't rely on sound or sight to navigate. Instead, they use chemical signals called pheromones. These pheromones are like invisible maps that guide ants to food sources, back to their colony, and even help them identify danger. When a scout ant finds food, it walks back toward the nest, releasing pheromones along the way. This chemical trail acts as a message. Follow me. There's food this way. Other ants from the colony pick up this scent and begin following it, reinforcing the same path by adding more pheromones as they move. That's why ant trails become so strong and organized. Every ant that walks by strengthens the path a little more. Now, when you decide to block that trail, you're not just disturbing a random line of insects. You're cutting off their communication channel. Imagine you're driving using GPS and suddenly your map disappears. That's what happens to ants when their trail is interrupted. The moment you place an obstacle, like a stick, your finger, or water, right across the pheromone path, the ants reaching that point suddenly stop. At first, the scene might look chaotic. Ants bumping into each other, some turning back, some moving in random directions. But don't be fooled by this apparent disorder. This confusion phase is actually a part of their problem-solving process. Ants use their antennae to sense pheromone molecules, and when they can't detect them, they switch into search mode. A few of them will wander in different directions, exploring the area around the obstacle to see if they can rediscover the scent on the other side. Once one ant manages to find a way around and reconnects with the original trail, it begins to release a fresh pheromone line. Within minutes, the rest of the colony follows that new path. And just like that, the line of ants reforms, bypassing the obstacle as if nothing ever happened. This adaptation shows just how intelligent and flexible ant colonies are, even though individual ants aren't particularly smart on their own. It's their collective behavior, known as swarm intelligence, that makes them appear so organized and strategic. Blocking their trail is like challenging a small army, and that army always finds a way to regroup. Interestingly, the reaction also depends on the type of obstacle you use. If it's something physical like a stick or a rock, ants usually find a way around it pretty quickly because the pheromone trail still exists on either side of the object. However, if you block the path with something like water, soap, or alcohol, it becomes much more complicated. Over time, they'll create a completely new trail, a process that might take minutes or even hours depending on the distance and size of the colony. What's even more fascinating is that ants remember their previous routes. Some studies have shown that certain species can use visual landmarks, or even the angle of sun plus light to help guide them when chemical trails are interrupted. In other words, if you block their path, some ants might still reach the destination using memory cues, or by following other workers that accidentally find the right direction. Their coordination and resilience are truly impressive for creatures with such tiny brains. Another interesting detail is that not all ants react the same way. For example, army ants and weaver ants are much more organized and disciplined. When their trail is broken, they can rebuild it incredibly fast by spreading out in fan shapes until they reconnect. So, the next time you see a line of ants and decide to block it, remember, you're not just stopping random insects. You're interrupting a highly sophisticated communication system built on teamwork.